Hi everyone. Today we are going to see the continuation of exercise 8.4, fifth question, fifth subdivision. So here we are asked to prove the LHS equal to RHS using the trigonometric identities. And in this subdivision, we are given in the LHS as cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equal to cosecant A plus cot A. So we are asked to make use of this identity, that is cosecant square A equal to 1 plus cot square A. So that identity we have to use it. Okay, as usual, let's start with the left hand side of the equation. So what is given in the LHS? So in the LHS we are given with cos A minus sin A plus 1. So that is divided by cos A plus sin A minus 1. So if you check with the right hand side of the given equation, you have cosecant A in it. So that you can get only by taking the reciprocal of sine, that is 1 by sine A will give us cosecant A. So to bring that form, what we can do here is we can divide this all the terms both in the numerator and denominator with sine A. That is what we are going to do here. So divide by sine A. So what will happen is, like, the equation will become like this. So cos A by sine A, next minus sine A by sine A plus 1 divided by sine A. Okay, and the whole divided. So this is only the numerator part. We have to continue the same thing for the denominator part also. So the denominator also divide with the sine A. So cos A by sine A plus sine A by sine A minus 1 by sine A. So now on dividing, what it will become? So cos A by sine A, we know that it is equal to cot A, and minus sin A if you cancel will become 1. So the denominator also, this will get cancelled. So sin A when we divide, it will become 1 plus 1 by sin A is cosecant A. So this whole divided by the same, like a cos A by sin A, here also cot A, and here plus 1 and minus cosecant A. Okay, now we are going to slightly rearrange this equation, the numerator first thing, like cot A plus cosecant A. So that is what the answer I am looking for at the end. So let me bring that separately. Cosecant A plus cot A. So this is what we need at the end. So that alone we keep it separately, and the remaining is minus 1 and the whole divided by, in the denominator we have cot A plus 1 minus cosecant A. So probably we can write that as 1 plus cot A minus cosecant A. I'm not changing anything, just rearranging, that's all. Okay, now in the numerator we have a minus 1. So in the place of that, what can we use? And in the beginning of the question, we are asked to use the identity cosecant square A equal to 1 plus cot square A, isn't it? So in that identity, what will be the actual form of that? will be the 1 plus cot square A equal to cosecant square A. This is what the actual identity is, right? So if we transpose this cot square A to the right side, what it will become? It will become 1 is equal to cosecant square A minus cot square A, isn't it? So in this place of 1, we are going to make use of this. So this one in the place of 1, in the place of minus 1 here, we can make use of this one, like this part. Okay, so what it will become? So this you can take it as a rough work, not into the main sum. So now let's continue with the main sum. Okay. So it will be, so I have already separated this cosecant A plus cot A, isn't it? Because that is what the result I need. And in the place of minus 1, in the place of 1, we are using this part cosecant square A minus cot square A. So remember to put it inside the bracket. Okay, so put it inside the bracket, and the whole divided by the main sum. We have the denominator, we have 1 plus cot A minus cosecant A. Okay, and so what this will become? So as usual, this is reserved for the final answer, so we are not going to disturb that. And now coming to this one, we have a minus here, and what it is of the form cosecant square A minus cot square A. It is of the form like A square minus B square identity, isn't it? So that can be written as A plus B into A minus B. Hope you remember this one. Better I will write here once. Okay, so A square minus B square, so which is equal to A plus B into A minus B. So this identity we are going to apply here. So what this will become? Cosecant square A minus cot square A. So this will become like this. So inside the bracket we can split and write. So cosecant A plus cot A, this is one term, multiplied by cosecant A minus cot A, right? And close the bracket, close the main bracket, and this divided by the whole thing divided by, so already we have 1 plus cot A minus cosecant A, isn't it? Okay, now so in the numerator part, if you watch, what you have is like here also cosecant A plus cot A. This is the pink color one, and inside that bracket we have a cosecant A plus cot A. So we can take as common, right? We can take as a common term. So it's really like, so this will become like a cosecant A plus cot A, right? So if I am taking this one and this one as common, and so we will be having a bracket and 1 minus, as we are pulling out it's common, we have 1 minus, and what it is in the remaining is cosecant A minus cot A. Hope you're following me. Good. Fine. So here the whole thing divided by 1 plus cot A minus cosecant A. So this we can put it in a bracket. And now look into the bracket term of that. So as I told you already, this we have already reserved for the answer. This is what we are going to get in the right hand side, cot A. And now look into the bracket term. Here we have 1 minus, if you take the minus inside, it becomes cosecant A, minus into minus, they become plus cot A. And in the denominator, the whole divided by, in the denominator we have the same term 1 plus cot A. Okay, just the order is changed. So if we want, we can write in the same order. So 1 minus cosecant A plus cot A. So just we are rearranging and writing, we are not disturbing the equation. Now if you look into this, in the numerator 1 minus cosecant A plus cot A, in the denominator we have the same 1 minus cosecant A plus cot A. So what we can do, so we can go ahead and cancel these two terms. The total terms get cancelled and we are left with what? We are left with, the remaining is cosecant A plus cot A. So which is equal to the RHS. So therefore LHS is equal to the RHS. Hence proved. Hope you liked this video. If you understand the way I teach, please subscribe and share with all your friends. And thank you for watching this, and I will meet you in the next video. Bye bye. See you.